Okay, good morning, everyone. This is the last day of the CLEI conference and the last day of the last talk of the of this track. Sorry, and here we have our the PhD Lucas Brown. He is Oracle Database Multilingual Engine Program Manager, and is giving us a talk about the Oracle Database Multilingual Engine. This talk is about 40 minutes long. Welcome, Lucas.
Thank you, Aurelio. Gracias para la introducción. Soy Lucas. Muy buenas tardes desde Suiza a todos. And that was it with Spanish for today. I feel more comfortable giving the talk in English, but I do speak Spanish, so feel free to ask questions in English or Spanish. My Portuguese is very, very, very basic, so I will probably not understand. So today we're going to talk about the Oracle Database Multilingual Engine and Apex, which is Oracle Application Express, or in other words, how to unlock cual VM's full power in the database. My name is Lucas. I'm a program manager and an ML lead developer at Oracle Labs. Please feel free to reach out to me, be it on the conference app, be it on Twitter, on LinkedIn. through email. I'm very happy to hear feedback like on this talk, but also like on the project itself. Whatever question you have, don't hesitate to reach out. So let's get into it. What is the vision that we follow in the MLE team? Nowadays, when we develop apps, very often we do that in the cloud. And I started a poll here in the app to ask, what is your favorite programming language? Not too many people did answer it so far. I have 2 responses. Let me see. Okay, I have 2 out of 3 people tell me Python. 1 tells me Java. Okay, so Python and Java are definitely one of some of the popular languages. And then another popular one right now is JavaScript. And which language do you take for your app, right? But the one that you find popular, the one that you feel most comfortable with, right? That's sometimes a choice. So I have some languages on this slide here that may be your choice. But it's not only about the language, it's also about the ecosystem. So what that means is when we talk about JavaScript, we will also talk about, okay, how do you actually bundle and deliver that? And then we have to talk about Webpack as well, which is a very handy tool to bundle your JavaScript application into a single bundle that you can then use in the web browser. And another important aspect is whether there is open source libraries available for that programming language. So when we talk about JavaScript, we certainly want to talk also about NPM, which is this very popular site for open source JavaScript modules, which has by now more than 1 million modules available at your fingertip, free of charge, free to use. So that's great. And like for other languages, you know, we have other stuff. So for Python, we have, for instance, for Java, you know, we have Gradle for building Java. We have Maven, where we get a lot of Java code. We have Ruby with Rails, and so on and so on. Now, when you program your app, at some point, your app might or might not be data intensive, right? If it is data intensive, might manage a lot of data, could be that you start talking to a database, for instance, the Oracle database, right? If your application is data intensive, this might mean that you ask a query to the database, you get the result, you process that result, you maybe, you know, insert some new records in some other table, query again, or like update some other rows. It goes forth and back, forth and back, forth and back, and that's a network round trip all the time, which might performance-wise be suboptimal if your application is really data intensive and goes forth and back a lot, right? Also, imagine machine learning workloads, right? Very often what we do if your training data for machine learning algorithms in the database, the first step is to basically take out all the data of the database and then use your whatever, you know, NumPy or whatever it is to build your model, right? That means the first step, getting all the data out of the database, takes a lot of time if it's a lot of data. And it might also be a security challenge, right? While it's in the database, it's well protected by very well-defined, established ways, right? In the database, you can very nicely control like who has access to specific records or specific columns, specific tables. You can define all of that, and the data is secure. Like once you take it out, it's out in the wild, so to say, right? And then of course it's your application. I mean, it's the responsibility of your application to make sure your data doesn't get compromised, right? So there are challenges when it comes down, you know, to process data outside the database. And this is exactly why all the major database vendors offer you a way of programming your application logic directly in the database. Now, in the case of Oracle, this language that you can use inside the database is called PL SQL, right? Which allows you to write procedural logic inside the database and run your application close to the data, where the data resides in the database. Now, PL SQL is very powerful. It's Turing complete. You can do basically everything with it, but it comes also with a couple of challenges, namely that, you know, you can only use it within the Oracle database. So if you want to move your code somewhere else, it might be tricky. Another thing is that if you take university graduates, not many people learn PL/SQL during their studies, right? But almost anybody learns Python nowadays or learns JavaScript, right? So we have a difference there. Also, if you look at open source, there is open source code. Like there are some PL/SQL packages that are open sourced, but they're more in the number of hundreds than millions, right? So there's a huge gap there. And much of the PL/SQL code that gets run in companies is actually not open source because it took them a long time to develop that code, right? A lot of energy. They won't open source that. They will keep it for themselves. So that's why our mission in our team is basically take all the good things, of common purpose programming languages and open source code and execute those languages in the database. And this is exactly what the Oracle database multilingual engine is about. The vision is to really execute arbitrary languages within the database. That's the vision. I will talk later about how much of that vision has been realized until today and what is like on the roadmap for future work. Now, the key enabling block of the multilingual engine as it is today, and as it will also be in the future, most probably, is GraalVM. GraalVM is a product that came out of Oracle Labs. Also, multilingual engine is developed by Oracle Labs, and Oracle Labs is basically the research and development branch of Oracle. Just to mention that as well. Now, before we dive into MLE and its architecture and so on, I quickly want to spend some minutes on GraalVM, that you understand the kind of the core technology that the multilingual engine, or MLE for short, is built upon. So GraalVM, in one sentence, is a multilingual embeddable virtual machine. So what that means, like for the multilingual aspect, it really means that it's an interpreter and a compiler. It's a runtime for almost any language, right? So be it bytecode languages like Java, Scala, Groovy, be it dynamic languages like JavaScript, Ruby, or Python, or even be it languages that can compile to LLVM bitcode like C, C++, Rust, whatever it is, right? GraalVM runs them all. You can even bring your own language. So if you have, a domain-specific language or a very specific domain, all you need to do is writing a language interpreter for it, right? Using the GraalVM API for that, which is called the Truffle interface. And then GraalVM takes care of the rest. So you write your language interpreter, GraalVM takes then care of compiling your code when appropriate. So when it's run, often it gets compiled and just in time, right? Takes care of, memory management, thread allocation, whatever you need. GraalVM does it for you, and that's really the nice part of it. The way it does this, it uses this Truffle API across all its languages. So you have basically all the language code gets transformed, if you want, to a unified representation. And then that then also allows you to very easily combine code coming from different languages and run them all in the same execution engine. GraalVM is also embeddable. So, you can use it to just run your Java workload. You can use it as a drop-in replacement for Node.js. It is embedded in the Oracle database, which is called the multilingual engine, and which is like the main piece of this talk. We also have a prototype in labs where we try to integrate it into MySQL. It can be run standalone. Now, why should you use GraalVM? Well, first of all, it's high performance. So let's say if you just run your Java application, if you run it on GraalVM instead of OpenJDK, let's say, it's very likely that the performance gets better, right? And that's because the compiler in GraalVM has very, very many very advanced modern optimization steps built in it. So it's really at the top of programming language and compiler research, right? It also has fast startup. So GraalVM has a feature called GraalVM native image that allows you to compile your application into a native executable or into a native library that you can then call, like as if it was compiled, let's say, from a C program with GCC or something like that. for a Java program, for instance, that really means, you know, all the parts of the Java standard library, which is pretty big, all the parts that your application won't need, if it's just, let's say, a hello world, all those parts basically get kicked out, right? So what you get in the end is a native executable that is very small. And when you start it, it's very quick because it doesn't have to load, you know, hundreds or thousands of classes before it can even start, right? Doesn't have to do that. And the memory footprint, because it doesn't have to load all those classes and because of a number of other reasons, is very, very low, right? It's GraalVM is also polyglot, multilingual, right? As I just showed on the slide before, since all these languages get into a union representation, you can mix and match languages with seamless interoperational characteristics between them, right? So you can have JavaScript script that, you know, calls into, I don't know, a Python package that uses a Ruby gem to do something, right? Or you can actually have a Java application that does something with JavaScript, gets the result, and renders it with Ruby, and, you know, in between does some machine learning stuff with Python. So you get all of that in the same runtime, which means in the same process. You don't have to start another interpreter process for that other language, right? It's all in the same runtime, same process, same memory space. No need to communicate to another process through shared memory or whatever. So really nice thing. It's also this polyglot aspect. And then last but not least, GraalVM, the community part of it, is open source. Right, so you can see what's inside, you can track the feature progress, you can make feature requests, you can report bugs, you can, you know, even propose contributions yourself. So very, very nice. Also to mention, since we have a couple of students and other academics in this session here, right, there's a very strong research community around GraalVM. So especially in the, you know, compiler, programming languages, and so on community. They have published quite a number of papers at quite impressive, at very important conferences. So very strong research community, very strong academic performance by that team. GraalVM itself comes in these two flavors. So there's a community edition, which gives you basically all the functionality, and everyone can play around with it. And then there's the enterprise edition, which is really made for enterprise users. So you have advanced security features, you have advanced performance characteristics or improvements. And this one, I mean, if you just want to build a proof of concept or something, you can also use it, right? But if you then use it for commercial purpose, you have to purchase a license. Or you can just use the multilingual engine, which has, you know, GraalVM Enterprise built in. And, you know, the multilingual engine is available already today in the Oracle database 21C. So if you use, let's say, Oracle database in the always free cloud tier, you have it for free already today, enterprise quality, GraalVM. And that kind of closes the loop on GraalVM. So what is the Oracle database multilingual engine? What is MLE? It's basically GraalVM in the database, so embedded in the Oracle database. So project started as pure research, you know, approximately 8 years ago. So we also see a bit the time horizon, what it takes from, you know, a first prototype that is somehow hacked together until, you know, getting it actually ready to be integrated in an industry strong product like the Oracle database. So I was part of about half of that journey, and I can say from personal experience that was very, very interesting. Like going from this research prototype to actually do all the aspects that you need to do if this becomes an actual product, has to be secure, you know, has to fulfill all kinds of functional and non-functional requirements, has to be reviewed from all perspectives and angles and so on. That has been a very, very interesting journey. The first release of that, as I already said, was last December when Oracle Database 21C got released in the Oracle Cloud. And in its first version, MLE supports JavaScript execution, dynamic JavaScript execution through a PL SQL package called DBMS MLE. And I'll show you that package in a minute. As already mentioned, MLE is powered by GraalVM. So let's dive shortly a little bit into the MLE architecture. You see a lot of boxes, in this picture. I'm not going to go into details of those, since I would like to make this more kind of a practical talk. There is a blog about this. You see the QR code in the top right corner. There's a blog about this that explains all of this in detail. Let me only highlight a few points here. So first of all, MLE is integrated with the database operating system layer, you could say. Right? So the database has a layer to abstract from the operating system, since the Oracle database runs on several different platforms, right? And MLE integrates with that layer. Important here is that we block file access and that we block network I/O, right? Because we don't want to have JavaScript user code access files in the database. That would just be very, very, very dangerous from a security perspective. This layer also controls memory allocation and threading, and basically integrates with this OS emulation below, which is important because MLE has to be a good citizen in the database, just like any other database component. So in the database, you have a thing, for instance, called the resource manager, that can shut down any component or any process that is taking too many resources. And MLE is just the very same because it integrates with that layer. Okay, next point, we use Substrate VM, also called Graal VM native image. And this provides us with fast startup and low memory footprint. Low memory footprint is really essential in the Oracle database, since the Oracle database is a multi-process system and every session gets its own process. And, you know, since on some installations you have very, very, very many parallel sessions, you have to make sure that the footprint of one session is small. And Graal VM native image helps us with that. And one highlight for the JavaScript people, we run a very, very recent version of ECMAScript, so we can play around with the newest JavaScript features that are available. Now, when you use the CBMS MLE package, the first thing that you usually do is you create a context, and you get an explicit context handle, and then in this context, you can evaluate code. Now, each of these context handles, they map to a polyglot context, which is the Graal VM concept for a context. Context is something that, a concept that appears in JavaScript, but also other dynamic languages, and basically captures runtime states, so stuff like global variables. Now, in our design, all polyglot contexts relate to the same polyglot engine. And this is important because the engine is the thing that does compilations, right? So if, let's say, in context 1, you run some code over and over again, it gets hot, the engine starts compiling it. At some point, the compiled code is available. So from that point on, in context 1, when this function is called, you can use the compiled code and be very quick. Now, by having all contexts share the same engine, you will also profit from that compiled code if you run that code in context 2, right? So we made sure that we can reuse compiled code as much as possible within the same session. Right, so now let's get into how this CBMS MLE package actually looks like. So the basic workflow is as follows. So first of all, you create a context, which then gives you back this context handle called context. And then you can use this context to evaluate code through this in the CBMS MLE package. So you give it the context handle, you give it the language, which right now only JavaScript works there. And then you give it the JavaScript program basically as a string. So here it's a very easy, simple hello world program that gets executed. Now, if your JavaScript program should communicate with other scripts or other functions, other PL/SQL procedures, you need a way to import and export variables into and from that JavaScript program. And that's why we also have an API for that. So on the PL/SQL side, you have export to MLE to export a certain variable identified by a name. Here it's called val, to the MLE context. And then later on, you can also import from an MLE context a result, for instance. And then on the JavaScript side, we have an internal module called MLE.js bindings. You require that module, right? Require is just a keyword to include JavaScript code from a module into your script, right? you get that bindings module, and then you have an import value and an export value function in that module that you can then use to like import your value from PL/SQL and then export it back to PL/SQL. So that's how you exchange values. And then obviously for a programming language that runs in the database, it's very important to be able to talk to the data, so to run SQL. Right? And that's why MLE does also have a SQL driver, so an internal module called MLE.js Oracle DB. When we designed this API, we tried to model it as closely as we could to the Node Oracle DB module, right? So Node Oracle DB is the Node.js driver that you use today already when communicating to an Oracle database, but like from an application that runs outside the database, right? So ideally, you could just copy paste code that works for Node Oracle DB. You could copy paste it into MLE and then run it in the database when that makes more sense. We have a couple of differences, right? Since we are in the database, yeah, we run the code synchronously, and that's why we have a synchronous API, no promises. So we don't return promises, but we throw exceptions if there are errors. And since we are already in the database, we don't really need to set up the connection, right? So, you know, what we do typically first is we call default connection to get something that looks like a connection object, because you need that to execute stuff. But actually, we don't set up a connection because we're in the database already. Then you can define your query and you can then execute it. You can give your binds. So here we bind this 3000 to this first bind parameter here. And then, you know, you can use this, the usual interface to process your result. I have prepared a very quick demo for this. Now, before I can show you this, I have to explain what Apex is, because their query runs with Apex. So Apex, in one sense, is a low-code development platform that enables you to build scalable and secure enterprise apps with world-class features that can be deployed anywhere. So let's take that step by step. You develop your Apex app once, and then it's optimized for desktop as well as for your iPad or for your mobile phone, right? So Apex does that for you, don't need to worry. What you can do with Apex is like visualizing and maintaining database data very easily, and then build your app on top of it using Apex. Many things in Apex can be done by just clicking together basically the relevant things, and you don't have to be a programmer really for that. However, if you know a bit of SQL or a little bit of PL/SQL, you can use all those skills to do even more stuff with Apex. Other distinguishing characteristics are that the IDE in which you develop is actually a web browser, right? So you don't have to install any specific software. Web browser is enough. Also, you don't need a compiler, really, right? The programming code is declarative. It gets stored in the database and it gets run by Apex. You don't have to compile anything. There's no code generation involved. It's really just PL/SQL. And when you use Apex, the page generation is very efficient because all the data processing happens in the database, and in the end, you basically compute one HTTP response, which gets sent back to the browser. Okay, looking at my watch, we have time for a very, very short demo. So this is Oracle Application Express Apex running in the Oracle free cloud tier. First of all, I can go to SQL Workshop just to show you SQL commands. So that's a SQL shell. But in Apex, you not only can run SQL, but you can now also run JavaScript with MLE. So I can do something like console log hello. Right? If I run that, I should get a hello here in my console. Now, what I can also do is I can go to PL/SQL, and I can now do the whole thing end to end that you basically saw in the slides before. So I have my context handle, I have my JavaScript code, which is basically I import a value, I add 7 to it, I export the result. I start on the PL/SQL side with a value 42, create my context, export this 42 with the name P1 input to the context. Then I evaluate this JavaScript program that we've just seen in this context, then I import the result, which should be 42 plus 7, right, 49, and I print this. So if I run this, I should get something like 49. But I made PLC equal, I think. Why is this not working? Oh, it is now. Okay. I didn't change properly from JavaScript to PLC equal. Thank you. So I now got 49, which is what I expected. Now, what you see is that this was like 22 lines of code or so. And actually, the business logic is just take one value, add 7 to it, and store this in another field, right? So what I can also do instead of writing this, and a lot of it was boilerplate, like creating the context, you know, moving variables between PLC equal and JavaScript, and so on. So what I can also just do is I can use Apex directly, not the SQL commands part, but for actual Apex. I can create an app with these text fields and the button. On the button, all I have to write is this one line, right? Where I say like, take this input field, divide it by 1. This is because the input field is in text, and by dividing it by 1, I get a number, then I add 7 to it, and I store this in this output field, and that's it. Now, if I run this, right? Oh, great. That's actually not cool. And of course, this worked just before, as always. Oh, goodness gracious. Okay. Let me see whether I can try it through password here. Hopefully it works. Nope. Okay, let me try that password then. No, really. Okay, this is really unfortunate. You gotta trust me that I just tried this before this call and it would work. Okay. That's not funny. But one more attempt, otherwise you just leave it here. With this password, maybe? Oh, okay. Here we go. So you have this input field, you have the add 7 button with the JavaScript logic, and you have the output field. And if I write 42 here, I get 49, right? So it's really one line of JavaScript code. And we can get rid of all the boilerplate by using Apex. Okay, so going back to the presentation, you can use MLD in the Oracle Database 21 standalone, but you have to write a little bit of boilerplate code. If you use Apex instead, you know, it gets much simpler and you can focus on the business logic. That's the takeaway message here. So that's almost it. Like, of course, we have ideas how to take it from here, right? MLD is by far not completed. So what we want to do in the future is we would like to improve the developer experience. So better code management for these NPM modules. So right now you have to write quite a bit of boilerplate code to get a module working. You can, but it's a bit complicated. We want to simplify that. We want to simplify the debugging experience. Right now, you have this kind of printf style debugging with console.log. We want to improve that. In the Oracle Database 21c, Oracle released a new SQL type called JSON. And since JSON and JavaScript are a very good match, right, we obviously want at some point support JSON as well in JavaScript. Then we want to have support for more modules from NPM. So NPM modules, they work off the shelf, typically when they work in a browser as well as in a node environment, because that basically means they are general enough to work anywhere. Then they typically also work in the database. But then there are modules that, you know, write to files or read from files, which cannot be run as is in the database for the security reasons that I already discussed. But you can emulate a file system on top of, say, let's have a table with a blob column, and let's store the files in there, and then you're safe, right? So we want to have such support more modules by having such shins, as the JavaScript people call it, for file system or operating system or stuff like that. Also, MLD's performance as of today is pretty good. It's more or less on par with PL SQL in most of the workloads. But GraalVM offers you a lot of tricks that you can play, and we did not play all those tricks yet, by far not. So we want to further improve there. Now, if you say, this is great, how can I get more information? This is how you get started. So there's a number of tutorials and blogs, and the first one is actually linked to GitHub, where we have tutorials and blogs that explain you how to get started, how to use MLE. Now, the easiest environment to run MLE is in the Oracle always free tier in the Oracle Cloud. Everybody can use that, and it's always free, right? It's a trial for a number of days. No, it stays free basically forever. Anybody can register there, and you just have to provide your credit card details. You will never be charged as long as you don't upgrade from the free tier to the paid tier, right? Now, if you don't want to provide your credit card, which I can totally understand, if you're a student or an academic, you can actually use the Oracle Academy program, where you have to register your university and then your faculty and then your students. And then you can get access to a lot of Oracle products, either for free or at the reduced price, including the free tier cloud. And then you don't have to provide credit card details and all of that stuff. And you even get some money that you can spend within 12 months or something. So really nice program if you're an academic or a student. Also, like if you then start playing around with the free tier and you say, this is cool, but the resources I got, like these 2 databases or this 2 terabyte of data or these 2 CPUs, that's not enough for what I do because I run heavy workloads. We do have another program called Oracle for Research, and I strongly encourage you to make use of that. So if you do research, you need resources from us, reach out through that program, and we can see whether we can give you a grant and help you sponsor that research. Okay, with that, I'm done. Thank you very much for listening. I guess we may have time for 1 or 2 questions at most. I don't see any questions here in the Zoom room. Let me check the app here. 0 questions asked. Okay.
Okay, thank you, Lucas. I have a question slightly related to the talk, and it's about this process from going to research to production. If you can talk more about that experience, it would be really interesting for us.
Sure. I mean, sure. I can give you a couple of examples. I can probably not give you all the details how Oracle works, but like imagine when you do a prototype, like you just work typically with English. You don't have to care about national character sets, right? You don't worry about how do I integrate with the operating system, or am I a good citizen? Do I care if I use too many resources and other services get slower, right? I just hack together a prototype that I can show a demo and awesome numbers, right, when I do performance measurements. Now, the moment when this got scheduled for the actual release, right, we started working with other teams in Oracle for functional testing for this globalization, right? I mean, we have to support all kinds of character sets and then all kinds of languages. Your error messages have to be very good and follow a standard, right? You have a team that just checks the syntax and the grammar of your error messages, and then you have another team translating all those error messages to all languages like German, Spanish, Italian, whatever, right? You have to start worrying about time zones, and time zones to actually change from time to and locations, right? And tons of other things that you never. Collations, right? Sorting out, well, we didn't have to bother too much with that. I'm very lucky that we didn't have to, but how do you sort words? It depends on the language, and there's different rules for it, right? So tons of issues. That was a very, very interesting journey. But we also, at the point we were scheduled for release, we got help from other teams that specialize in those domains. So it was more about collaborating with those, right? But very, very interesting.
Nice, thank you. And the other question I have is about adoption of this Graal VM. So how is it going?
So there are 2 things, right? So one is the adoption of Graal VM as a whole, right? Inside or outside database. The other one is about Graal VM in the database, so MLE, right? So for Graal VM itself, I don't really know the numbers. I mean, if you look at Twitter and so on, you see a lot of activity. So there are definitely many people using the community edition, and we do have a number of customers that are using the enterprise version. So there's definitely a lot of traction on Graal VM, specifically, the native image part. for LVM. Now for MLE, we don't have good numbers yet how much it's adopted. It's in Oracle 21C, which was declared an innovation release, right? So it's not a long-term release. So we certainly don't have anyone, hopefully, running any critical business on that, right? We do. So what is the cool thing is if you run stuff in the cloud is actually that whenever somebody runs into a crash, right? This creates an incident report, and like a couple of minutes later, we get automatically a bug created and assigned to our team, right? Nice. So that machinery is pretty cool. And so from this, we do see that people are trying out stuff in the cloud. So for instance, we had somebody that wrote Python instead of JavaScript. And this crashed because we had an earlier prototype at some point in Python. Not relevant, but somehow, just that string kind of escaped to the actual product, which of course it shouldn't. But then you type anything and nothing bad happens. You typed Python and it crashed. So we got that, we fixed it. And the cool thing with the cloud, of course, is this continuous development as well. Like, 2 weeks later, whenever the next cloud release was, this was fixed. So now you can write Python and we will just say like Python is not a language or something like that, until it hopefully becomes one day, right? So this is called multilingual engine. So the vision really is to run many languages. At this point, it's only JavaScript. The GraalVM itself offers a lot of languages, as you've seen on the slide, right? And all those languages are potential candidates for being run in the database at some point. But as I tried to explain, the integration is a non-trivial thing, and that's basically what keeps our team busy.
Sure, thank you. Very nice talk. We ran out of time, so only thing left is to say thank you to you. We hope to meet again in another activity. Really, thank you. Bye.
Thank you for having me. Goodbye.
Ingresamos a la era de cloud. Para 2025, todas las compañías utilizarán tecnologías cloud y más del 85% de las aplicaciones empresariales se implementarán en cloud. Como líder mundial en la provisión de servicios TIC, Huawei ofrece un servicio experto de cómputo en cloud, servidores, almacenamiento y red. Una plataforma comprometida con proveer confiabilidad, apertura y servicios globales.
The future used to feel pretty simple. I had a plan. Finish college, find a job, move to a new city.
See you later.
Lately, it just feels up in the air.
It's not the way I wanted to spend my senior year. I was supposed to have my first internship this summer, but that didn't happen.
Our world is changing so much right now. Life is changing, plans are changing. I don't like being on the sidelines. I want to be a part of the change.
This is a moment to write my own story, to be a trailblazer and inspire others on the way to achieving my dreams.
Adversity can either pull us apart or bring us together, and I want to step up and be part of a culture that moves towards change, not against it.
No matter what this year throws at me, I have dreams that I'm chasing.
I have a lot to give, a lot to say, and I'm not waiting anymore.
I want to learn from the best and be part of a platform where I can impact lives, billions of them.
And I'm done waiting for things to go back to the way they used to be.
This is my time, our time.
I'm ready to make an impact now.